AP Calculus AB, Unit 7, Day 4, Office Hours. This is the worksheet. I should have tried it already, checked your answers. Here are the answers, I guess, real quick. If at a glance, I guess I could show you the answers for the first page. So this is the first page. These are the new problems. 1, 2, and 3 are new. Those are the answers. 4 is also a new idea, intermediate value theorem. Very simple though. 5 is extreme value theorem, old idea, but we're reviewing it again. And then the other answers I just have listed here at the top. 6, true mean value theorem, true intermediate value theorem, true extreme value theorem. 7, once. 8, no. 9, B. 10, A. 11, C. 12, A. 13, A. 14, D. 15, D. And 16, D. So let's try these problems right now. So mean value theorem for derivatives, find all the values of C as guaranteed by the mean value theorem. So that's specifically the place where the actual derivative equals the average derivative. But you got to find the actual derivative first. Make sure the function's continuous on the closed interval and differentiable on the open interval. It is, it's cubic, no problems. Set it up, f prime average. Even though you're not asked to find this, you have to. But show the setup, f4 minus f of 2 over 4 minus 2, label it. So if you plug 4 in here, that's 64, 65. Plug 2 in, that's 9. And so we get 56 over 2, which is 28. So that's f prime average. And then the actual derivative, we can find using simple power rule, 3x squared, and we're going to set it equal to the average derivative. And figure out where does the actual derivative equal the average derivative. So we can divide by 3. Take the square root of both sides, plus or minus. Better have plus or minus in your work. I don't care if we end up not using one of the answers. It should be in your work. So we have positive square root of 28 over 3 and negative square root of 28 over 3. I'm fine leaving it just like that. You don't have to rationalize all your answers. You got to be between the endpoints of 2 and 4. So what is, can we estimate this? 28 over 3 is about 9. Square root of 9 is about 3, right? That's negative 3. That's about positive 3. This is one we're going to use. Not because we always throw out negatives, but because the endpoints don't include it, right? So the answer is square root of 28 over 3. If you want, you could break this up, rationalize the denominator, take the square root of 4 out. Actually, no, can't take square root of 4 out. Yeah, 4 times 7. And so you could write this as 2 root 21 over 3. Sure, that's fine too. But I'm just telling you, I don't have to have that done right now. If there's multiple choice and that's how the answers are presented, then yeah, you got to do it. Okay. Is this a continuous function? It's a sine curve, which is continuous and differential with a kind of linear part added to it. So it's kind of a sine curve ramping up. So I think it meets all the conditions. Let's find f prime average, f of pi minus f of 0, over pi minus 0. F of pi would be 2 pi plus sine of 2 pi is 0. F of 0 would be 0. It's going to be 2 pi over pi. So f prime average equals 2. So then we got to find the actual derivative. F prime of x equals 2 plus 2 cosine 2x. And we're going to set it equal to the average derivative and solve. So 2 cosine 2x equals 0. Cosine 2x equals 0. 2x cosine equals 0 at pi over 2 plus pi k. There's no reference angle. There's no quadrants. Divide by 2, x equals pi over 4 plus pi over 2k, infinite answers. We just want the ones between 0 and pi. So that's going to be pi over 4 and 3 pi over 4. You need them both. You need all of them. Okay. So this is the main new thing that we learn, and you're going to have a problem on it on your next test. Okay, continuous function, differentiable, good. Find f prime average. It's just the slope of the secant line connecting the endpoints. It's going to be f of 2 minus f of negative 1 over 2 minus negative 1 is rise over run. F of 2 is going to be 8 plus 2 is 10 minus 4 is 6. Negative 1. It's going to be negative 1. That's going to be negative 6. 2 minus negative 1. So that's going to be 12 over 3, which is going to give you 4. F prime of x is 3x squared plus 1. We're going to set it equal to 4, the average derivative. So we're going to try and figure out where the actual slope equals the average slope. I'm going to solve it. 3x squared equals 3. X squared equals 1. Squared both sides, plus or minus. Better having your work. Positive 1 and negative 1, but we want the ones between the endpoints. And negative 1 looks good because it's on the endpoint, but we can't do it. Can't do it if it's on the endpoint because the derivative issue is two-sided. So on the edge, you don't consider it. So c equals 1. Now you better get an answer on any of these. If you don't get an answer, either the function wasn't differentiable and continuous, or you've made a mistake somewhere because it's guaranteed. Guaranteed. Okay, intermediate value theorem pretty much just says you can hit every value between, the endpoints if it's continuous. Now this says f prime is continuous, so f prime of 2 equals negative 5 and f prime of 6 equals 3. Well, f prime is a function, so this applies to any function. And f of x must have what kind of point for some x between 2 and 6? Well, the special kind of point I can think of is if f prime equals 0, which it clearly will, which, I'm pretty sure f prime of x equals 0 is going to happen, right? So we call that a critical point. We also call it a stationary point. But more specifically, critical point. All right? EVT, find the absolute max of the function with the endpoint. So these are easier than optimization. So we've been doing these a lot. Got to find critical points. Derivative, 6x squared minus 18x plus 12 equals 0 undefined. Probably try and factor out the GCF, which is 6. I'm just going to make life a lot easier. And so it's going to be x minus 1, x minus 2. And so x equals 1 and x equals 2. But they got to be between the endpoints. So this guy's out because it's well, I'm sorry. I'm in the evaluate theorem. These are your critical points. You got to make a table. X, f of x, original function, 2x cubed minus 9x squared plus 12x. Endpoints, negative 1, 1, and 2. Now, an endpoint and a critical point are the same. Who cares? If you get critical points outside the endpoints, don't calculate them. But they should show up in your work. So this is going to be negative 2 minus 9 minus 12. That's going to be negative 1. That's going to be negative 23. Plug 1 in, it's going to be 2 minus 9 plus 12. That's going to be 5. Plug 2 in, that's going to be 16 minus 36 plus 24. So that's 4. So we're looking for the max. This is the max. By the way, this is the exact same work if they asked you for the min. But let's write the answer nice enough. Absolute max is 5 at x equals 1. At least that. I'm not looking for justification. In optimization, I am. Okay. Okay, number 6 says, if f is continuous and differentiable on a closed interval and f1 equals -2 and f3 equals 4, then which of these statements are true? And name the theorem that supports your answer, and maybe show some work too if it needs to. There exists a point C where the derivative equals 3. Well, that sounds like mean value theorem, right? So I think to verify that, we have to find the average derivative and see if it's coincidentally 3, and then we can make that claim easily. So f of 3 minus f of 1 over 3 minus 1, this is work I need to see. It's going to be 4 minus -2 over 3 minus 1 is going to give you 6 over 2, which is 3. So this is true by the mean value theorem for derivatives specifically, because there's another mean value theorem that we haven't talked about. Right? There at least f of x has at least one c where the function is 0. Well, that sounds like 0 is between -2 and 4. That's true. There's no work to show. The reason is intermediate value theorem. Right? It's got to go through all the values from -2 to 4 if it's continuous. There exists at least one c, 1 to 3, for which the value of the function is greater than or equal to 4. Now this one's kind of weird. You have endpoints, right? So that means you know that f of 1 is -2, right? And f of 3 is 4. And you know it's got to go through all the values in between, but it might go above or below these values, right? And we know that because it's continuous and differentiable on a closed interval, that extreme value theorem applies, which guarantees you have at least one maximum, absolute max and absolute min. And this is saying that some value of c might be greater than 4, or even more, at least once. And so I'm going to say that's extreme value theorem. This is true. There will be an absolute max that might be 4 or even more. So true extreme value theorem. I mean, for sure, it already happens at the endpoint, so it's for sure going to equal 4. Now, could we get any more than 4? Maybe. If they don't, this statement's still true. Number 7, Brianna drives from AG to SF 270 miles in 5 hours without stopping. Likewise, Alex drives from Santa Maria to LA 165 miles in 3 hours. At least how many times must they have been traveling at the same rate, but not necessarily at the same time? But so this idea is the average speed, right? Average speed equals f prime average, right? Is going to be, for Brianna, 275 miles over 5 hours gives you, what's that, 20, 40, 55 miles per hour for Brianna, average speed, right? And the average speed for Alex would be the rise of a run, 165 miles over 3 hours equals 55 miles per hour. That's Alex's average speed. So since they have the same speed, they had to both at least be going that speed once themselves. So that's the speed we know they were both at least going. So average velocity or speed for both is 55 miles per hour. So both must have it at least once, maybe more. Right? Okay. 8, Jen's left AG driving continuously and differentially because it's really the only way you can drive. After 1 hour, it was 50 miles away. After 4 hours, he reached a point 250 miles away. He later received a ticket in the mail for breaking the 65-mile-an-hour speed limit. Was that a ticket he could reasonably fight? Why? Now let's assume the judge knows his calculus, or can follow his calculus, or whatever, or maybe doesn't know his calculus. We'll see. We're going to assume he does. So Jens can't just lie to him straight out. But we could say, well, Jin's average speed for his whole trip after 4, I'll make a little table here. So there's 0, there's 1 hour, he's 50 miles, 4 more hours, he's reached at 250 miles an hour, 250 miles. So we say, well, the average speed of his whole trip is 250 over 4, which is 62.5 miles per hour. So Jin's gonna be like, hey, Judge, man, my average speed is 62.5 miles an hour. Like, I went at least 62.5 miles an hour once, but, let me off. But the judge knows his calculus, and the judge says, well, let's calculate your average speed for this chunk. And this chunk, it's 50 miles an hour, because maybe you got caught on the camera or something. The average speed for this chunk is going to be 250 minus 50 over 4 minus 1 is 200 over 3, which is 66 2/3 miles per hour, which is greater than 65 miles an hour. And he at least was going the average speed at least once. So the answer is no, since somewhere between 1 hour and 4 hours, he was going 66 2/3 miles per hour. At least once, maybe more. There you go. Watch out for those judges that know calculus. Okay, number 9. Let f be the function given by f of x equals x cubed. What are all the values of c that satisfy the conclusion of the mean value theorem of the closed interval? Okay, this is what we've been doing. Got to find the average derivative first. Label it. It's going to be f of 2 minus f of -1 over 2 minus -1. F of 2 is going to be 8. -1 cubed is -1. We get 9 over 3, which is 3. So that's the average value of the derivative. What are the values of the c? So we're going to take the actual derivative and set it equal to the average derivative. Figure out where that happens. So x squared equals 1, square root of both sides, plus or minus, -1 and +1. But you got to throw out the edge point. So I'm going to say 1 only. Okay. Next one, we have a function. If c is the only real number such that f is equal to 0, then c must be between what? So only. So they're saying there's only one 0, there's only one x-intercept of this graph. Where does it have to happen without doing it some other way? So we're going to use intermediate value theorem on this. And I feel like the easiest way to do that is to make a quick table, because we have a bunch of values in here, and they show up more than once. And I think you plug these in real quick. So it's -8, -6, -3, -1, 1, that's 3. 0 is going to be 3. 1 is going to be 3. 2 is going to be 8 minus 2 is 6, plus 3 is 9. 3 is going to be 27 minus 3 is 24, plus 3 is 27. Which one do we have to go through 0? These guys. Could we go through 0 in between any of these other points? Yes. I'm not saying that. But if they say only, then that's got to be the spot, right? It's got to be -2 to 1. IVT, intermediate value theorem, is what I was doing there. 11, consider the function. At what intervals are the hypothesis of the mean value theorem satisfied? On what intervals is the hypothesis satisfied? Where can we use the mean value theorem? I'm not even asked to do it, but where could we do it? So this is a square root function, right? But the +2 on the inside moves it over 2, right? So we definitely can't use it to the left of 2. So this is out. This is out. 2 to 7 should be good. But it's going to be continuous on closed interval, and it does have vertical tangent here. So you might, oh, we got to throw 2 out. Yeah, but the differentiability part says between the endpoints on an open interval. So it doesn't have to be differentiable on the edge to use it. So, I mean, the domain of this function alone is x is greater than or equal to 2, right? So that's why you just throw out a and b for sure. 12, let g be a function defined and continuous on a closed interval a to b. If g has a local minimum at c, and c is between the endpoints, which of the following statements must be true? Okay. Now it could be any or all of these, or none of these. It says, if g prime exists, then g prime has to equal 0. Well, local min, relative min, couldn't it happen at a sharp corner or sharp point? So I'd be like, yeah, this one for sure has to be true. Or no, like it could be undefined, right? You could get your critical point when it's undefined. This says that GC has to be lower than GB. Does the relative minimum have to be lower than the edge? No. I can draw all kinds of pictures. I mean, you have relative minimum, and then the edge is even lower, right? I mean, or there could be other, that one's out. G is monotonic. What monotonic means, another word for it, is 1-to-1. I think we talked about this last semester, but I'll bring it up again. Monotonic means it's like the definition of function, but for both ways. It passes a vertical line test because every input has exactly one output, but it also passes a horizontal line test because every output has exactly one input, which isn't always true. So you can think like a cubic passes vertical line test, but also passes horizontal line test. A parabola is a function, but is not monotonic. So monotonic means you can't have the same y value more than once. So is that true? I would say that's for sure false, because I don't think you can have a relative min or max on a monotonic function, right? And this has a relative min, so the function definitely goes up, goes down and up. It's not monotonic. Now the tricky thing here is that, yeah, sure, relative mins could be sharp corners, so the derivative could be undefined for that critical point, but it said there's a key word. It says if it exists. If it exists, because undefined, it doesn't exist. If the derivative exists at c, then it has to be 0. It has to be 0. And that's true. Because if the derivative doesn't exist, then yeah, it would be undefined. So that one's kind of tricky. It's going to be 1. At first, I was thinking throwing 1 out. Okay, 13. F of x equals cosine x. The mean value theorem guarantees that somewhere between 0 and pi over 3, the derivative equals what? So they're not actually asking you to find the value of where it happens, but they're saying, what's the guarantee? So you got to find the average derivative. Because somewhere between 0 and 3, the actual derivative equals the average derivative. So let's find the average derivative. Set it up, which is going to help you make less mistakes. It's going to help you get partial credit when you do make mistakes. Cosine pi over 3 is 1/2. Cosine 0 is 1. So you get negative 1/2 times 3 over pi. So it's going to be negative 3 over 2 pi. Negative 3 over 2 pi. We didn't actually find the c values, but that's what has to be true. Okay, 14. Consider the following graph of this function x sine x on the domain negative 4 to 4. How many values of c in negative 4 to 4 appear to satisfy the mean value theorem? Those are that guarantee. Well, from negative 4 to 4, we could actually visually do this. We could say, hey, look. Well, I mean, we could do it. We could say, well, let's find f average. And f average would be f of 4 minus f of negative 4, or 4 minus negative 4. And if you plug 4 in here, it's going to be 4 sine x minus negative 4 sine negative 4. Okay, sorry, 4 sine 4 over 8 plus plus. Now, sine negative 4, you guys know the sine function. It's an odd function, so when you plug in 4, you get the same answer when you plug negative 4, but it's going to be opposite. So this is going to be 4 sine 4 minus 4 sine 4, which is going to give you 0 over 8, which is 0. Right? And then we're going to set that equal to the actual derivative. The actual derivative is x times cosine x plus sine x times 1 equals 0. You say, okay, well, when is that true? Well, now it's getting a little harder. I don't know if we can do this without a calculator, but here we have a picture of it. When does the slope have 0 slope? Here, here, here. We didn't even need to do this work. We can see it right here. F prime average equals 0, right? And I'd say there's 3. Okay. 15, let F be continuous, differential, and monotonic. Okay, that means it passes horizontal from 3 to 8. So there's another point here that they didn't give you. Table shows 4 function values. Which of the following statements must be true? That f of 8 is bigger than 9. I don't know. This one went up 5. This one went up 4. This one went up 3. So are we assuming it's going to go up 2? And for sure be at 10? No, I don't think that's true. I think f of 8 is probably for sure bigger than 8. Because if it's monotonic, you'll notice that the function is going up. And so that means the values have to keep going up. If it's going to pass horizontal line test, they can't go down. F prime of 5 has to be 0. It has to be positive. Greater than 0. Now, here's the deal. With monotonic function, it kind of means they're going up the whole time or down the whole time, but you could get a plateau. And that's still monotonic. That still passes horizontal and vertical line test. So it doesn't have to be positive. It has to be greater than or equal to 0. It can be negative. So I think that one's out. F prime of C equals 3 at least one time between 3 and 7. That kind of sounds like the mean value theorem. Let's try that. Let's find F prime average from 7 to 3. I'm just going to start with this. Sometimes I have to be a little more creative. F of 7 is 8. F of 3 is negative 4. So we get 12 over 4, which is 3. Yeah, for sure. Mean value theorem says actual derivative is going to equal the average derivative. So I'm going to say that's going to be 3 only. Now, by the way, if this somehow didn't give us 3, that didn't mean that this is wrong or even unprovable. You might start looking at smaller chunks to see if you could get an average of 3 between a smaller chunk that's somewhere between 3 and 7, and it'll happen on a small chunk, which means it'll happen on a bigger chunk. So it worked out really nice at time, but sometimes you got to look at more specific, smaller intervals. 16, all the following functions satisfy the conditions of the mean value theorem on negative 1 to 1, except for which function? They got to be continuous and differentiable, right? Now the sine curve is continuous and differentiable everywhere, right? Inverse sine, I don't know if you guys remember this. It's like a sideways version, right? You flip it across y equals x. But it's principal values only. So it's just this chunk. And while it is continuous from negative 1 to 1, and it's differentiable between negative 1 and 1. So we're good there. This function right here, x to the 5/3, we could actually, you can plug anything into it, so it is continuous. We could check the derivative of it real quick. It'd be 5/3 x to the 2/3. Can you plug anything into this? Sure. Negatives are fine. It's an odd root. So we're good there. The next one, The function x to the 3/5 is continuous. You can plug anything in you want. Let's take the derivative. The derivative is going to be 3/5 x to the negative 2/5, which means that at f prime of 0, it is undefined. So that one's out. And that might be the right one. I don't know if there's more than one. We'll check the last one. Last one's a rational function that has a vertical asymptote at x equals positive 2. As you go to infinity, it goes to y equals 1. So I'm doing a really quick rough sketch. You guys should be able to crank these out. If I plug in something bigger than 2, it's positive. If I plug something in less than 2, like 0, it's going to be negative. So this is what the graph looks like. Okay? Now from negative 1 to 1, I mean, this graph has issues to where you couldn't use mean value theorem. It's not continuous. But since we're only looking at negative 1 to 1, just this chunk of the graph, we're good. So it's good to know your functions. And that's it.